Hi everyone, I am here with another video on Python lists. So this video focuses on accessing the elements in a list. So one thing we must understand is Python lists are zero-based index. What is meant by zero-based indexed? So like C arrays, Java arrays, the Python lists also would start at zeroth position and end at length minus 1 positions. For example, the first element is stored at zeroth position means the last element will be stored at length minus 1 position. So to demonstrate that, let us take one example. L as 10, 20, 30, 40 and 50. This list contains 5 elements. I would like to get the first element. How can I get that first element? I must give the index 0. So the first element is stored at index 0, second element at 1, third element at 2, fourth element at 3 and so on like that. The last element will be stored at the position length minus 1. Then, so let me just print this value. So what will be printed? 10. Next, I would like to get the third element. How can I get this third element? Third element is 30. I must give the index 2. Yes, we got 30. Suppose I would like to get the last element. Last element can be accessed as the last element here is 50, length minus 1. What is length here? 5. 5 minus 1, that is 4. Let me run this code. We must get 50. Yes. So this is how we access the individual elements of a list. So the first element starts at 0th index and the last element ends at length minus 1 index. That is the basic thing we must remember. Next one. To understand it further, let me consider one example. Performing linear search in a list. So the elements given are 3, 5, 7, 8, 2. So I will be reading key from the user. The element to be searched is read from the user. I am naming that as key. Then I can write like if key in the list. What does this in operator will do? In is a membership operator. If key is there present in list, it will return true. The result of this if statement will be true. If key is not there in list, the result of this if statement will be false. So print true. Yes, the element is present. Else print the element is not present. So what is that I am using here? I am using in operator to check the presence of an element in a list. Okay, so if I run this one, based on the value of key given, it will give either true or false. So let me give 7. Yes, 7 is present in the list, so it will give true. Suppose if I give some other value which is not there in the list, it must give false. Let me give 9. What is the value it prints? False. Okay, good. But the actual linear search is, if the element is present in the list, it must give the position of that element. If the element is not there, we must state that there is no such element. So to implement that linear search algorithm, what I can do is, if the element is there in the list, then give its position, found at position, comma. How to get this position? There is a method in lists by name index which will retrieve the position of the given element. So how to use that method? L dot index. What is the element to be checked? Key. Yes. If the element is there present, then it will give that position. Otherwise, no such element or element not found. Okay, now let us run this code again. Let me give the key as 7. I must get the position 0, 1, 2. Yes, found at position 2. Let me run this again and give something which is not there in the list. 9. What does it print? Element not found. So uh, what is the thing that we have to observe here? By using in operator, we can check the presence of an element in the list. And what is this one? Index. By using index method of list, we can get the position of the given element if it is there. So what is the danger in this one? If the element is not there, then this index will throw an error. So what is the name of that error? Value error. So for that reason, before using index, it is better to check whether it is really there in the list or not. Okay. So if you directly use index, if the element is not there, it will return an error. Okay. So this is linear search algorithm that we can apply on the list of elements. Next one. To further understand the access of the elements, I will be considering the task sum of the elements. So here I will demonstrate how we can loop through the list to access the elements of the list. So for this I am considering the list 10, 20, 30, 40 and 50. Actually, to find the sum of the elements, there is one built-in function available in lists which is nothing but sum. So by using that, we can directly get the sum of L. So let me print this one. It should print 150, yes. But as we have considered this sum of the elements as an example to demonstrate this loop through the list, I will be applying our traditional method of finding the sum of the elements of the list by considering element by element. So for this reason, I will be considering simple for loop. So initially I will assume sum equal to 0. I am considering simple for loop for j in list. You see, here I am not using any index or any position to get the elements. I am directly accessing the element. For j in L means for every element in L, what is that to be done? That every element is to be added to sum. This is a simple for loop in Python. Here we are not talking about the position. We are directly accessing the element by element. Okay. So of course this j will initially consider first element. Next it will consider second element. It will consider the elements in a sequential order. Now let us print this one. We must get 150. Yes, this is one approach. Next I will be considering for loop with range function. So for this also I will assume sum equal to 0 for I in range. What is this range? Range function will tell. So it will consider some numbers in the given range. The starting default value will be 0. The ending value will be as per the given as per the mentioned statement. So here I am considering the ending value as len of L. That means it will stop at len of L minus 1 and starts at 0. Then sum equal to sum plus L of I. Here we are accessing each and every element of the list by its position. Okay, so print sum. So it must print 150. This is another way of looping through the list to access the elements. I will tell about one more way, which is by using while loop. So for this also I will be assuming sum equal to 0. I will be taking the starting index as 0. Then I will write the while statement like while I less than len of L. Then sum equal to sum plus L of I. Then print sum. It must also print 150. Yes. Sorry, it will not print 150. Why? Because it is falling into infinite loop. What is the problem here? I didn't use I equal to I plus 1. In range function, it will automatically take one after the other. In while statement, we must give that. So I am stopping and I am running this again. Now it must print 150. Yes, very good. So the first 150 is the result of sum of L function. Second 150 is the result of simple for loop. The third 150 is the result of for loop with range function. The fourth 150 is the result of looping through the list using while statement. Okay, so this is how we can get the elements one after the other by looping through the list. Next, for example, if you are interested in particular elements, for example, I would like to consider every alternative element. Then accordingly I can change this range function and I can get. I can change this increment of I value in while loop and I can get it. So that sort of alterations we can make according to the necessity. Next, similarly, let us try to understand this loop through the list by finding maximum and minimum elements of the list. The list I am considering for this purpose is 4, 5, 3, 2, 8, 6. There are 6 elements in this list. The maximum value is 8 and minimum value is 2. To find the maximum or minimum elements of the list, there are built-in functions available. Max will find the maximum element of the list, min will find the minimum element of the list. For example, print max equal to comma max of L. It will print the maximum value in the list. And similarly, I can use minimum equal to comma min of L. Okay, so we can directly use these built-in functions to get the largest value of the list or smallest value of the lists. But sometimes in problem solving we may need to do this manually. So for that reason I will explain how to find the maximum element of the list or minimum element of the list by looping through the list. So we must learn this also. Though we can use these ready-made functions, we must also be familiar with the conventional way. Why? Because in problem solving we may need to do it manually also. Then let me consider m maximum equal to L of 0. This is the logic we follow to find the maximum element. The first element is assumed as maximum and then we will loop through the second element onwards and then we will compare with each and every element. Now if the assumed maximum is lesser than current value, then update maximum to that current value. Okay, now print maximum equal to comma maximum. Okay, this should also print 8. Yes. So the first maximum is the result of max function. The second maximum is the result of finding the maximum by looping through the list. Okay. Next, the same logic can be applied to find the minimum also. So let me just write that code also. Minimum equal to L of 0. The same logic we are applying. The first element is assumed as minimum. Then loop through second element onwards. 1 comma len of L. If minimum is greater than current element, update minimum to the current element equal to L of I. Okay, print minimum equal to minimum. That's all. So let us run this code. Yes, the first two lines are the output of built-in functions. The second two lines are the output of looping through the list. Okay, this is how we can access the elements by looping through the list, and we can perform some manipulations, comparisons with the list elements. Next one. Elements of the list can be accessed through negative index also. So this is allowed in Python. So what is meant by negative indexing here? Suppose I would like to get the last element. I can give the index as -1. The index 0 starts from left onward, left to right. The negative index starts from right to left. I can access the elements from right to left with the help of negative indexing. Suppose I would like to get the last element. One way is, earlier we have seen, to get the last element, the index is taken as length -1. So here I can simply give like -1. This will also give the last element. It must print 10. Then suppose I would like to get the first element. How can I get it? Start from rightmost side, -1, -2, -3, -4, -5 and -6. To get the first element, I must give -6 or simply minus length. We got the first element. Suppose I would like to print 2. How can I go to 2? Start from rightmost side, -1, -2, -3 and -4. I want to get the value 2. I must give print -4. That's all. It will give 2. So this is how we can use negative indexing to access the elements. Next one. Till now we have worked with accessing individual elements, or even when we used loops, we were accessing element by element. We can access a group of elements at once with the help of list slicing. So how can we do this? Suppose in this example, I have considered the list as 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would like to get the first 5 elements from the list. I want to print only the first 5 elements. So I will be applying list slicing here. Carefully observe how I am applying. The starting index is 0. What is the ending index? It works like a range function. If you give 5, it stops at 4. For example, I would like to get the first 5 elements. I will give 5. Why? Because it will stop at 4. Then let me run this one. Yes, we got the first 5 elements of the list. Here I am starting with 0. That is the obvious starting position. Even if I omit, it will not be a problem. Let me run this again. Yes, we got the same. Now I would like to store the first 5 elements into another list. Can I do that? Yes, we can do it very much. L of the first 5 elements from L are shifted to L1. Now print L1. Yes, what are the contents of L1? 1, 2, 3, 4, 5. So like this we can take a portion of one list and put it in another list. Okay. Next, suppose in this list I would like to consider the last 5 elements. How can I do that? Print L last 5 elements. Last 5 elements are 6, 7, 8, 9, 10. What is the starting index of that last 5 elements? Starting index is 5 colon, ending index is 10. If I give 10, it stops at 9. So let me print this one. Yes, 6, 7, 8, 9, 10. As 10 is the obvious last position, I can omit that also. Even then it will print the same. Yes. The first index and last index need not be specified. Why? Because they are obviously the starting positions and ending positions. For example, I would like to get every alternative element of the list. How can I get that? So I won't give starting position, I won't give ending position. Then what is the step value I would like to give? 2. Or else first let me write like this. Then I will omit this one. The starting position is 0, ending position is 10. What is the step value? Like a range function, step value is 2. That means it will consider 1, it will skip 2, it will go to 3, skip 4, 5, skip 6 and so on like that. Let me print that. You see the last line of the output 1, 3, 5, 7, 9. Okay, now I can omit this one. Omit this one, even then it will work out. Why? Because 0 and 10 are the obvious starting and ending positions. Now by using the same kind of logic, I will be printing the reverse of the list. How to get this reverse of the list? I will be printing like this, colon colon minus 1. What does this mean? If I do not give starting index and ending index, for a negative step value, the starting index will be taken as the length, ending index will be taken as this starting position minus 1 and then minus 1. This is the default assumption and it will produce the reverse of the list. Yes, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, etc. We can talk a lot about this list slicing. By using list slicing, we can alter the elements of the list. We can remove some elements, we can add some elements into the list. We can perform so many things by using list slicing. List slicing is very powerful feature of Python lists. So I think that it deserves a separate lecture, and I will make another video that covers this list slicing. Okay, next let us consider one application of this list slicing. Find the number of duplicate elements in a list. Here you observe the elements. The elements are taken as 10, 10, 20, 20, 60, 50, 30, 40, 40, 40, 70. How many duplicate elements are there? So 10, 10, one duplicate element is there. 20, 20, another duplicate, 2. 40, 40. How many duplicates are there here? 2. So how many total number of duplicates are there here? 4. How can I write a program to find the number of duplicate elements in this list? So let us attempt this one. The list is given like this. Let us loop through this one. For I in range len of L. Okay, as we have to find the total number, let me consider one count variable, dcount equal to 0. Normally the sum and the counts, these will be initially assumed as 0. Later on gradually we will increment them. Then the condition for this is if L of I, if the current element is there in the subsequent part of the list, that means L of I plus 1 colon. I need not give the ending index. Why? Because if I do not mention, it will go till the end. If L of I in L of I plus 1, DC count plus equal to DC count plus equal to 1. That means DC count or D count? Yes. D count equal to D count plus 1. Print number of duplicates equal to D count. Okay, let us run this code. Yes, it has produced exactly what we have expected. Number of duplicates in this scenario are 4. Okay, so that's all, folks. So I hope you understood how we can access the elements of the list. I have given various examples. So let us quickly summarize what we have covered in this video. So first I have started with simple accessing of elements of the list by using index. Then we have considered one linear search application in which we have experimented with in operator and index method. Okay, next we have considered finding the sum of the elements. So as an example of looping through the list, I have considered this sum of the elements. Of course, we can find the sum of the elements by using built-in functions, but most of the times while problem solving, we may need to do it iterating through the loop also. Iterating through the list also. So for that reason I have explained this logic. This we can do in multiple ways by using simple for loop with range and while statement. Next, similarly I have considered another example to explain loop through the list. So that example is finding the maximum or finding the minimum. Next, negative indexing. Negative indexing is possible with Python lists. So using which we can extract the elements accordingly. Next, accessing a range of elements with the help of list slicing. So this is very powerful feature, and if we understand it, we can write programs in a very flexible and easy way. Okay, next. As an application to that list slicing, I have considered finding the number of duplicate elements in a list. Okay, so this is all we have discussed in this video. I hope you understood the content, and if you have understood, please comment, and if you liked the video, please like it, share it among your friends and subscribe. Thank you.